Hello everyone, welcome to Zoltan's Maths. Today we're going to be taking an in-depth look at the proof of root 2 being an irrational number. So, to start this proof, we're going to assume its contradiction. So we're going to assume that root 2 is rational. Now, what does it mean for a number to be rational? If root 2 is rational, that means that it can be written in the form a over b, where a and b are elements of the integers. B is greater than 0, since we obviously can't divide by 0, and that the greatest common divisor of a and b is equal to 1. Now, this is a very important part of our proof. You'll see why later, but this is basically saying that this fraction a over b is in its simplest form. So if I have 1 over 2, 1 over 2 is the same as 2 over 4, but 1 over 2 is in its simplest form, and this is not. And the greatest common divisor of 1 and 2 is 1. The greatest common divisor of 2 and 4 is 2. So basically we just want this fraction, root 2 a over b, to be in its simplest form. And what we're looking is if we can find a way, if it's not in its simplest form logically, then we have a contradiction. So we'll see how that works later. So now that we have root 2 equals a over b, we can manipulate this using some algebra. So this implies that by squaring both sides, we have 2 is equal to a squared over b squared. And that implies that 2b squared is equal to a squared. Now, this is key, because now what this is saying is that a squared is even, since it's 2 lots of b squared, which implies that a is even, because the square of any even number is going to be another even number. So we can write a is equal to 2k, that's just another form of a that we're writing in, where k is an element of the integers, right? And now we can just sub this back in to our original. So let me star this here. Let's sub a is equal to 2k into r star. So now we have 2b squared is equal to 2k squared, which is the same as 2b squared is equal to 4k squared, which is the same as b squared is equal to 2k squared. Now this is very similar to what we just seen before with a squared, just the other way around. Now this tells us that b squared is even, which again implies that b is even. And this is where our contradiction comes about, because if a and b are both even, then they have a common divisor of 2, right? Because if you're an even number, you can be divisible by 2. So both a is divisible by 2 and b is also divisible by 2. So their greatest common, well, we don't know if it's the greatest, but a common divisor of both of them is 2, which is a contradiction to our original statement that the greatest common divisor between them, the only divisor between them, is 1. So this fraction a over b cannot be in its simplest form, which is a contradiction. So we can write our concluding statement: since a and b are even, they have common divisor of 2, which contradicts our original assumption. Original assumption that the greatest common divisor of A and B is equal to 1. Therefore, root 2 is indeed, by contradiction, irrational. And that's all you need. So, quick summary. We assumed that root 2 is a rational number with A over B in its simplest form. But by logic and algebra, we showed that these numbers, A over B, are both even numbers, which contradicts it being in its simplest form. Therefore, the only possible conclusion is that root 2 has to be irrational. Thank you.